Hello, fifth graders. All right, so obviously I'm still in the classroom if you watched the last video. I'm just making them all at once because these are easy. Uh, this is one of the saddest lessons because this is one that I love teaching. In fact, even in years when I didn't realize that I had access to this packet, I still ended up teaching this because I think factor trees are a lot of fun. I think you maybe had something to do with them in fourth grade, I'm not quite sure, but that's what this lesson is going to be about. So lesson 3 is just factor trees, and then lesson 4 does not continue with factor trees, which is kind of sad, but that's okay. So let's talk factor trees. All right. So first of all, a factor is a number that you multiply times another factor in a multiplication sense, right? So anytime if we have like 5 times 2 equals 10, 5 and 2 are the factors of 10, right? You multiply them together to equal 10. So factor trees are just breaking a big number down into numbers that you can multiply together to equal that big number. Okay, so they give you, for unlocking the problem, I don't even care about the story problem, all right? They give you 24. That's what they want you to find the factors of. All right, so 24. And then you kind of do like these little V or whatever, and then you just write 2 numbers that you can multiply together that equal 24. And the book starts you off with 4 and 6, so we'll follow what they're doing, all right? Because 4 times 6 equals 24, okay? But now, there's numbers that we can multiply together to equal these 2 numbers, so now we have to go one step further. So 4, well, numbers, and just to clarify in case you are not thinking about it, we don't ever use 1. If you get to the point where you have to multiply 1 times the number, well, that could go on forever, so don't do that. All right, so it's numbers greater than 1. So 4 is 2 times 2, okay? And the only thing that we can multiply together that are whole numbers to equal 2 is 2 and 1, so we can stop at the 2's. All right, so for 6, the only numbers we can multiply together are 2 and 3. Okay, so these are the factors of 24. We have 2 times 2 times 2 times 3 equals 24. And really, if you can figure out this, you can figure out all the different numbers that you can multiply together to equal 24, right? So 2 times 2 is 4, and we can multiply that times 3, that's 12. 12 times 2 equals 24. Or 2 times 2 is 4 times 2 more is 8. 8 times 3 equals 24. Obviously, we know 4 times 6 equals 24. So yeah, so those are the different ways that we can figure it out. If you guys have been here when we did things like figuring out what the possible volumes are and all the different dimensions, I probably would have like whipped out a factor tree just to figure out like what the breakdown is. So yeah, then in the next problem, so right below it, it says try this. And they give you 2 different numbers that you can multiply together and asks you, does it work out the same? And I kind of already just told you, right? So you could pick any 2 numbers. Let's do, I don't know, let's do 2 times 12. Oh, let's do 12. Now, 12 times 2. Okay, whatever. All right. Now, again, we could go 3 and 4, but I'm just going to keep doing 2s. So I'm going to go 2 here, and I'm going to go 6 over here. And then I'm going to go 3 and 2. Okay, so again, we have 2 times 2 times 2 times 3. So we have 3 2s and 1 3. Not sure if this will come up in 6th grade. Eventually, they're going to want you to write this using exponents, which we kind of have talked about a little bit, right? So if you remember, I'm going to erase this here. Just remember that it was 2 times 2 times 2 times 3. Okay? So we talked a little bit about exponents, right? 10 to the power of 2 is equal to 10 times 10, which equals 100. Okay, so this exponent is just, hey, multiply this number times itself this many times. Right, so 2 to the power of 10 is 10 times 10. If it was 2 to the power of 4, then it'd be 10 times 10 times 10 times 10, okay? Which happens to be 10,000. So this is a way of simplifying this, right? Rather than writing out all of this 10 times 10 times 10 times 10, you can just do 10 to the power of 4. Okay, So we have 2 times 2 times 2 times 3, right? We just talked about, like, you could have written, if these were 10s, right, you probably wouldn't have any issue with it being written as 10 to the power of 3. Well, the same thing works for 2s. So this could be 2 power of 3 times 3. And it means the same thing, right? We've got 1, 2, 3 2s. That's why our exponent is a 3. And then our base is 2, because that's what we're multiplying. 3, and if you wanted to get real technical, you can do it to the power of 1, but you really don't have to do that, because 3 to the power of 1 and 3 is the same thing. And this is actually more about saving time than anything else. So 2 to the power of 3 saves you from writing all these 2s, right? 3 to the power of 1 is actually making an additional mark, so you don't have to do that. That's kind of silly. All right, so let's take a look at one of these. Number 1 kind of walks you through it anyway, so we're not going to worry about that one. Let's do a fun one. Okay. We're actually going to do number 7. So just because that one looks like the hardest one. And that makes it more entertaining for you. All right, so number 7, they want you to do a factor tree for 540. Okay, so we have to break it down. Now, 540 maybe looks like an intimidating number. You can literally, so factor trees, kind of like we talked about before. Factor trees, you can do anything. I don't know if you guys can hear that lawnmower. It's the custodians here are mowing the lawn. The reason why I've kind of like stopped and jumped around is because I've had people popping in to talk to me. So anyway, so we could just do, if we wanted to, just go crazy, is we could just divide it by 2, and we could just keep breaking it down by 2 until we couldn't do 2 anymore, and then we could pick some other number. But let's not do that, because that will take forever. Instead, let's realize that 540, if it ends in a 0, then that means that it could be multiplied times 10, right? So 540 is 54 times 10. We're going to do 10 real quick just because it's easy. So there's only 2 numbers that you can multiply together to get to 10, and that is 2 and 5. All right? And a lot of times when I was younger, my teachers would tell me that when you get to the point where you have a prime number, so a prime number, of course, is a number that can only be multiplied by, like it doesn't have any factors other than 1 and itself, right? 2 times 1 is 2, nothing else times something is 2, right? So they would tell us just to circle them, just so that you know that you don't have to do any more with it. It's up to you if you do that. So 54, pause and think about it. All right, probably figured it out, but is 9 times 6. Okay, 6 is 3 times 2, and both of those are prime numbers. And then 9 is 3 times 3. Of course, those are prime numbers. Okay, so here is our prime factorization, or our factor tree. Now, when you write this out, you could go 3 times 3 times 3 times 2 times 2 times 5. That's fine. Or if I'd had like this 6 over here, it would have been 2 times 3, or it could have been 3 times 2 times 3 times 3 times 2 times 5. In fact, you know what? Let me do it that way so I can show you what I mean. All right, so we're going to have a 6 over here. We're going to have 9 over here. Let's do this. So we go 2, let's do 3, because I want to show you that this can be messy. 3, 3, right? So we still have all the same factors, but now they're in kind of a goofy order. What I like to do, and I think is probably considered to be the proper way to do it, I don't know if there's really like somebody sat down and said, no, this is exactly how you have to do it. I like to start with the littlest number and just work my way up, right? So we have 2, that's that one, times 2, there's that one, times 3 times 3 times 3, which is that one, that one, and then we have times 5. So again, this is a lot to write out, yeah? But we could just say that this is 2 to the power of 2 times 3 to the power of 3 times 5. And it's a little bit smaller. It means the same thing, just a little bit smaller and easier to write. Okay, you just count up like, okay, I've got 1, 2 2s, so it's 2 to the power of 2. I've got 1, 2, 3 3, so it's 3 to the power of 3. I have 1 5, so it's just 5. There you go. So, but that is the prime factorization for number 7. Any other ones that are fun? Let's see, number 8's kind of fun. Oh, let's take a look at number 9. So this is going to come up on your homework. Similar problem, though it deals with something slightly different. So it says, find a number that has 4 identical even factors. Each factor must be greater than 1 and can only have 1 and itself as a factor. So you need 4 numbers that are all the same. And because they can only have 1 and themselves as factors, that means that it is a prime number. And it has to be even. Okay, so an even prime number. Well, that's tricky, right? Because, well, what are the even numbers? You've got 2, 4, 6, 8, right? And forever. But this is 2 times 2. This is 3 times 2. This is actually 2 times 2 times 2. This is 4 times 2, and 4 breaks into 2 times 2. Okay, so notice that all of these can be divided by 2, right? So they all have 2 as a factor, but 2 is only 2 and 1. Okay, so this is the only even prime number. Okay, 2 is the only number that is both even and prime. Everything else can be divided by 2. All the other even numbers can be divided by 2, which means that they are prime. So 2 is our number, and then it says that there are 4 of them. So we've got 2 times 2 times 2 times 2. Now, it doesn't want the factorization. So, I mean, you could write 2 to the power of 4, but you still have to figure out what that is because it wants what's the number that its prime factors are 2 times 2 times 2 times 2. Okay? So, then we just multiply them together. And you can kind of do it any way you want to, but probably the easiest way is to make that into 4, that one into 4, so now it's 4 times 4. 4 times 4 is 16. So for number 9, a number that has 4 identical even factors, and every factor must be greater than 1, it can only have 1 and itself as factors, that number is 16. That was number 9, by the way. Which probably doesn't help since this is circle 2. There you go. All right. I hope you enjoyed factor trees. I love factor trees. Like I said, if we've been having class right now, probably I would make you do factor trees, and I'd give you all sorts of wacky numbers. You know, it'd be like, find the prime factorization of 1,285 or something insane like that, and you would just have to work it out, and it'd be fun. You'd love it. I promise you would. But since we don't have that, I hope that you enjoyed this lesson. All right, have a good day.